Alright, so in this tutorial I will show you how to make characters with customizable skin color, hair color, and facial hair color in your game in Godot. So please be advised that we are using 3.2.3 in this tutorial, so in the future, if you are watching this video, the Godot versions, like newer versions, might have changed this shading language, but so watch at your own discretion. This was the end of the disclaimer. So what are we doing here is we have a character that is built up of many different sprites, and I want to map certain colors onto this sprite based on user input. So how to do that? So first of all, here in our scene tree we can see that we have this skeleton named skeleton. This is what is this? This is a node 2D, which is the parent of all these different sprites. Some of the sprites are in just as regular sprites, like a pants. You can see that I can remove pants, I can remove mouth, I can remove facial hair, so these are like separate sprites that we are using separate sprites because we want the user to be able to customize the character to switch out sprites. So some of these sprites are just sprites, some of these are implemented in polygon 2D, like the body, for example, or the arms and legs. So these are implemented through polygon 2Ds, and some are implemented in sprites. It doesn't matter, it will work for everything. The important thing is that when you want to do the mapping, you will have to have a shader material at the root, because you want all of your polygons or all of your sprites to inherit this shader. So, even though my body and my arm is in different, so this is the right arm, this is a different polygon, and the body is also a different polygon, I want to be able to recolor them together, as you can see here. So that's why this shader material is added to my main node, and so not all will inherit from this. So for example, in a face wear, which contains only like sunglasses and stuff like that, we don't expect it to contain any facial hair or skin tone that should be changed. So this one will not have any material, but the other ones you will have to check this use parent material tick box on. And so here you have to be very careful, because in this node we have this skeleton node and we have this spine node, and then we have all these sprites. So if we want these sprites to inherit the proper shader, then we have to tick on the use parent material. Here we have to tick it in the spine, for example, and we have to tick it here in the skeleton too. So all of the children have to inherit from the material from their parents where you want to apply the shader. So that's a very important thing that I had to realize by myself. So yeah, be more careful than I was. So now I have my skeleton, no, not the skeleton, like basically the main node selected, which is called skeleton, but it is actually a node 2D, as you can see here. But anyways, so we have the shader material and this shader, so I will just remove it so you can see all these sprites in their glory. So I am going to use this ugly pink color, this ugly green, and this ugly cyan colors as like the placeholder colors. So what I'm trying to do is create a shader that will replace these colors. So this purple will be replaced by the custom skin tone color, this green will be replaced by the custom facial hair color, and this cyan will be replaced by the custom hair color. And so for that, you want to create that, you need to create new shader material, and here shader is going to be a new shader, and then double click will bring up our shader editor. So we want just a regular 2D shader, so we will have to add the shader type canvas item, And don't forget to add the semicolon at the end of each line there. So now we don't have any errors. We can move on. So what we'll need, we at least need like 2 colors defined. So we will just first go with the skin tone. So I will define a skin mask color and a skin color. So you can see here that I use this uniform keyword, and if I use the uniform keyword, then whatever I define here will appear as a shader parameter on our inspector on the right hand. And you can see that these are vectors with 4 dimensions, and 4-dimensional vectors in this shader language mean that red, green, blue, and opacity. So we have an alpha channel and we have the 3 color channels, and in this shader language the maximum value is 1 and the lowest value is 0. But if I click here on this color editor, you can see that it gets converted to this 0 to 255, like this regular I guess 24-bit color scheme with red, green, blue. And also, well, there is also the alpha channel, which is also like a 0 to 255 here. But in the shader language, while we are typing in the code, we need to use it like from 0 to 1. And so this is red is maximum, green is 0, and blue is maximum again. And this is going to be the skin color that we want to substitute our purple to. Okay, so we need to add a function which will not return anything, so it's going to be a void function called fragment. And fragment is the function that basically goes through each of the pixels and will perform some kind of variation or some kind. You can do anything in this function, and that will be done to each and every pixel on your image. So first here, what I want to show you is how to create a color. So I can just add color with all caps, and it will be a vector 4. And I will just, or here I could just, use, I guess, something like 1.0 and what is it, comma 1.0 and comma 1.0 and comma 1.0. So this is going to be white, and I need the semicolon at the end of the line there. And now you can see that just everything turned white because I switched the output color to white. So now all our sprite is white. Okay, but what we don't want to do that. We want to actually handle the colors that are in here. So what I could do is I could define like a 4-dimensional vector, and this will be called color underscore A, and I will just get it from the texture. So this is going to be texture with all lowercase and parentheses, texture all caps and UV all caps. So this will basically get the color of the current pixel based on the texture and the UV. So the UV is just basically how to map a certain picture onto a polygon. And so we need these 2 parameters for this texture function to get our current color. And what I'm going to do is I will just get color as a 3-dimensional vector from color a.rgb. So this will basically get our, so this is a 4-dimensional vector that contains red, green, blue, and alpha channels. And now we get the red, green, and blue channels and put it in a 3-dimensional vector. And I will also just create a float called A, which will just get the alpha channel from this color. And so here, for example, what I can do is instead of this just using 1 as the alpha channel, I will just use the A, variable A here. And you can see now that, so some of our sprites are not using this shader. So for example, the cloth sprite doesn't have either the skin color or hair, so nothing. So this does not inherit our shader, so it will not be changed, but every other sprite that inherits from the shader, you can see that kind of got recolored to white, because now we use the alpha channel. So the alpha channel here was 0 because this part is an empty part of our sprite and this part had some color, so the alpha channel has been kept. You can see that even there is some kind of transition in the alpha channel, so nicely we have replaced the color to this. But we don't want to do that. What we want to do is we want to replace it to our skin color. So maybe, you know, we want to see whether this specific color is our mask color or not. And for that, what we can do is we can calculate some kind of distance. And so we want the distance between the actual color of the pixel and the mask color. And this will basically look like here, if we have this mask color, it's only in 2 dimensions instead of 3, because I cannot draw nice pictures in 3 dimensions here. So this, our mask color has blue 1 and red 1, and maybe like this is the actual color of the pixel. So we want to see, okay, so this is quite far away, so we don't want to replace this. But if the actual pixel is the same, we want to replace that color with our skin tone color. So we can basically do that by using the mix function. So I want to change the color. So let me just put color here again. So once I put color here, then you can see that, okay, everything got back to normal, I guess. But I need to change this color. So I want to change the color, and this color is going to be a mix of our actual skin color. So this is the color that we will be replacing the original color, and a mix of our just the regular color. And we need to give in here some kind of number, so maybe 0.5. That would oh yeah, we need what skin color dot RGB. Sorry. So for that, and now you can see that basically this everything is mixed like 1 to 1. So if I change this color to something more real, like skin-like, it's just maybe something brown, I guess, I don't know. You can see that everything is just colored, like we mix these 2 colors together. So of course we don't just want to mix these 2 colors together like 1 to 1. What we want to do is we want to use either one or the other, and for that we can use the step function, which requires 2 floating point numbers. And if the first number is going to be bigger, so let me just give 1 and maybe 2 here, so you can see that now the second number is bigger, so we just use the original color. But if I change it to 0, then it just uses the skin color. So if the first number is bigger, it will just use the first color, and if the second number is bigger, it will use the original color. So what we want to do is, if this distance, like the skin color, or rather the skin mask color and the actual color distance is 0, then we want to use the skin color RGB. So maybe we can just add like the skin list here, and this one should be 1, I guess. Yeah, so, or like 0.01 is even good. So you can see that now if I add like 0.001, so you can see here that what happens is that near the edges where the color is not exactly our skin color, or rather it's not exactly the mask color, but it's a little darker, then now it's not working at all. And if I just change it to, I don't know, like this 1, then you can see that now it's just overtaking almost everything, but there's still some kind of purple around there. But if I increase this number even more, then it just overtakes everything. And so depending on, like maybe I can just no, sorry, I can just find a number that will kind of, you see, recolor. So here, for example, the arm just recolored almost the whole arm there, which is not really good. So we maybe want to fiddle with this value. Now it did not recolor the red part of the arm, but it still recolored the white part. So maybe you want to change this, but now that this is not recolored, this kind of small purple boundary just starts to appear again. So we cannot really find like an optimal value for there. So what you can do is, of course, you can just use like a uniform float tolerance, and this will be a hint range. And so this basically, let's just do it like this. So hint range, so it can be set from 0 to 1, and we can use this tolerance here instead of just hard coding a number. And now you can see that by adjusting this slider, I can adjust the tolerance, but this is like really far from optimal, as you can see, because if I just set it too high, then the color starts to bleed to parts I don't want to. And this is very simple reason. This is because the distance between the colors is like, if I want like this same color but darker, if I want this distance to be masked, then of course if this is a color, this is very different, but the distance is similar, so this other different color will be also masked. So instead of just blindly comparing two colors like we are doing in our current way, or like here, if we don't want just blindly compare these two vectors, what I'm trying to compare is the direction. So if this is like, this vector is much shorter, so the distance between this vector and my mask vector is quite large, but they point in the same direction, that I just still want to be able to mask this. But if it's like very close, or rather relatively close, but it's like a different direction, then I don't want this to be masked. And for that, what I'm going to do is I will be calculating the length of these vectors, and because once I have the length of them, I can just tune them to have the same length while keeping their directions. And I'm going to do that by first getting the length of the skin mask, which you can use this length function for that, and I will also get the length of the color, which is, I just call it C length. And what I will do is basically I will normalize these two vectors. So normalize, well, not really normalize, because normalizing would mean that the length of the vector will be reduced or increased to exactly 1. But what I'm going to do here is well, I still call it normalized, but it's not really normalized. So basically I am going to get the mask color and divide it by the length. So this would be if mathematically speaking, this would be the normalized color, but I will also multiply it by the length of the color vector, and I will going to do the same with the skin color. So this is the color we want to replace it. Alright, so now that we have normalized our skin mask color based on the color of our pixels, what we can actually do is let me zoom in to check how things work. So you can see here, let's just switch this around a little, and instead of the actual skin mask color, we will use the normalized version, or I call it normalized, but you know it's not normalized anyways. But the thing is now that what happened is everything that was black before became brown. So why is that? That is very simple to tell you, because once we normalize things, so if my actual color is black, so what's a black? Black is 0, 0, 0. So black has 0 length. So black, if I have the 0 length for the for my actual pixel value, then I will have to decrease my, so the normalized vector, the normalized mask will also be 0, so it will match up with our and when it will be matched, then will be replaced by the skin tone. But what we can do instead is, you can see that we normalize the skin color, and the skin color has the same brightness as what is the brightness of our current color. So it's basically, you know, the same ratio as the mask color. So the masking color, which is the purple, the masking color is related to the color of the pixel. That's going to be the same kind of ratio for our skin color will be modified. So if instead of here, I'm just going to use the mix skin color norm, and by that, once we've done that, you can see that now it's black because the skin color has been normalized to 0 length, which is black. You can see here that it's kind of darker around here. But what I want to do is I want to remove all this and I'll have some fine tuning. So now it's like only works properly if it's like a very small distance that I'm using, and I want to be able to like fine tune it a little better. So instead I will multiply this by 5 or something. Let's say 5, and now we can just play around and we can kind of see, we don't want this skin color to like overtake that part, so we reduce it a little. Oops, where did I go? Yeah, so I want to like kind of find a good tolerance value that works fine. Actually, low numbers work with this very good. And well, now we can do this, and we can do the same thing for all the other body parts. And basically, let me just copy and paste this whole ordeal that I've already prepared. And so you can see now that now instead of just the two colors of the mask and skin color, we have hair mask and hair color, and facial hair mask and facial hair color, and basically everything is done 3 times, and in the end we just mix these colors together. So this way we can separately change the hair and the facial hair colors. So I was thinking maybe I can, you know, just have like a facial hair and hair color have the same all the time, but maybe the players want to, you know, use like a very yellow and black combination or something like that, whatever. You know, I don't want to restrict the players and future sprite creators for the game, so that's how I decided to implement. And now that we have this, I will show you something else. So now what we can do is I can just modify one of my sprites. And so for example, what I can do here is I can, let me just create something very silly just for the sake of argument here. So I am going to make this, no, I don't want, I just want to fill RGB, and instead of having like this exact same color, what I'm going to do is I will just maybe use 150. So this is the darker version of that purple, and I will just export it as a PNG image, and let's switch that around in our Godot editor. Alright, so I switched around the this sprite. So you can see here in my right hand side in the inspector that now we have this like the dark purple block on the forehead of this character. And let me just remove for the hair and face hair. So you can see that now it has been changed to a darker color of the skin tone. So if I go back to and change the material color you can see that this is just basically whatever I do, it follows the skin tone. So this way, and what we can do, the problem with this, what we have it set up now, is that we cannot have brighter versions, but if we would set our mask colors to maybe just 155, let's just do like this, what will happen now? So you can see now that because this is basically the same color, but the mask color is darker, so I'm not sure what was the color here for that. That was 150. So if I set it 150 exactly, then the selected skin color will be appearing here, and the brighter parts will be brighter. So based on this, you can select like maybe a middle ground for your masking, and you can just have the sprite contain some darker and some brighter parts, and then this will be followed by your skin color. Alright, I guess this is the end of this tutorial. So now if you manage to follow this, maybe you learn something new about how to make chroma key or color masking or whatever you want to call it in Godot. And I hope you found this tutorial useful, and if you did so, then why don't you leave a like down below, or if you have any questions or comments, you can always just hit me up in the comments section, and subscribe if you want to see more tutorials now that I'm learning more about Godot. If there is something new that I come across that there is not a good tutorial already out there about on YouTube, I will be talking about that. Or if you are interested in the OpenSuspect project, I will be showing you more of the OpenSuspect code and some kind of devlogs in the future. And of course, once I have anything new about Linux, I will be also talking about Linux or free software stuff that I generally do. So if you are interested in any of those, subscribe to this channel, and I will see you next time. Bye bye.